Assalamu alaikum everyone and welcome back to another video. So in today's video we will be going to design a simple turtle robot in which we will be going to use three sensors, three IR sensors for the uh, movement of the robot and we will be going to use the PWM procedure in order to control the speed of the motors as well. So this is our task. Now we will be directly heading towards our code. So this is our code. As we all know, in case of Arduino IDE, we do not need to specify the ports, or we don't need to either identify which port we are considering as an output or which pin which we are going to consider as an input. So we just use the concept of digital pins and analog pins for the purpose of controlling the multiple devices that are being connected to the Arduino. So first of all, we will be going to create a variable for the speed A, which we will going to connect to the pin number 10. This is the digital pin, and for the motor first terminal we uses digital pin 30. For second terminal we will be going to use digital pin 31. As for the purpose of understanding, these two pins are for the motor driver module, which are connected to the input logic pins of the motor driver module for the first motor. And for the second motor B1, we will be going to use digital pin 32 and digital pin 33. And for the purpose of speed control, we will be going to use the digital pin 9. And these are the three sensor variables that we will be going to use. As we know that our IR sensor gives the analog value, but the latest IR sensor are being impinged on a module, so they gives digital value, but we will be going to use the analog pin for the IR sensor input, which will be represented as A0, A1, A2. So these are the setup in which we will be going to use the pin mode command in order to assign which our outputs and inputs. As we know, our motor B1 is the set as an output, and B2 is also as an output, A1 as output, and all these pins that we have all discussed earlier are our output. And from these are the output, because we will be going to connect all these terminals of the motor driver with the microcontroller. So microcontroller gives us the output that we read at the input port of the motor driver module, but the IR sensor gives the output to the microcontroller. So these output are considered as an input for the microcontroller. So these pins are considered as input pins. And by the help of analog write, we will be going to control the speed of the two motors. We will be going to select the half duty cycle, which is 250 for the both motors. We can change the speed of the motor according to our need, or we can say that according to our desire. So this is the L298 motor driver modules connections. For the forward movement, we will be going to generate the functions, and we will be going to directly call these functions when we are going to make the decision statements. So for forward movement, as we know that in order to go the forward movement, our motor 1 and motor 2 both are on in order to move forward. So we will be going to contain one terminal of the motor 1 is low and other term as high, and the second one is high and low. So in order to make the rotation in a forward direction, and for the right direction, we need to stop one motor, which is the motor right. So we will stop the right motor by giving it low, and the left motor is on, so that our motor can easily rotate, or our robot can easily turn towards right. For the turn left procedure, similarly, our first motor is on and our second motor is off. For the stop procedure, our all motors are off. So in this way we can generate the functions. Now these functions are called in these statements, in which we will be going to decide which sensor is on and which sensor is off. If our middle sensor is on, which indicates that we are traveling on a black line, then we can say that which will have to move forward. And for the left condition, this is our condition in which our left sensor is on and the middle sensor is on. And if our left sensor, only left sensor is on and by other are off, it will also turn left. So in this way we can generate the conditions. Now we will be going to head towards our Proteus, in which we will be going to discuss these, and let's see how this situation really works or not. So this is our Proteus, in which we will interface these three IR sensor modules and one motor driver module, and these are the two motors which will be going to use. So as we have made a common ground and the VCC, and a voltage is being applied to the motor driver, and these are the connections according to our pin planning that we have been applied. So now we will be going to test some conditions. As you can see, if our middle sensor is high, then we have the condition that both of our motors are on. So let's see, is it really works or not. So as you can see that our both motors are on. It turns in opposite direction because its connections are interchanged. When we change the connections of these two terminals, it can turn in the same direction. So now we will be going to test some other condition. If we can change this sensor output to 1 as well, then we have a condition that states that we will be going to turn left. So for the turn left, our right motor is on and our one motor is off. So you can see that our right motor is on but our left motor is off. So in this way we can specify each and every condition according to our requirement. So that is all for today's video. If you like, then don't forget to drop a like or subscribe. Thank you and Allah Hafiz.